Please be assured that the content presented has been meticulously verified by a qualified engineer and a team of researchers to ensure accuracy and reliability. Our planet, Earth, is a dynamic celestial body perpetually in motion through space, and among its most fundamental movements, its daily rotation on its own axis is profoundly influencing every aspect of life as we know it. This steady counterclockwise spin on its own axis is precisely what creates the familiar rhythm of day and night. It is a timeless cycle of 24 hours that has shaped biological rhythms, evolutionary processes, and the rise of human civilizations across millions of years. But imagine if this constant and reliable rotation were to slow down, even by just a tiny fraction. The implications would ripple far and wide, disrupting our daily lives, altering climate patterns, and challenging the stability of natural systems we take for granted and rely on. To grasp this fully, let's first revisit the basics. Earth completes one full rotation on its axis approximately every 24 hours, a precise period that defines the length of our standard day and synchronizes clocks worldwide. It is this very rotation that generates the apparent eastward movement of the sun across our sky, delivering the breathtaking moments of sunrise in the morning and the gentle fade of sunset in the evening, marking the transition from light to darkness. Now, picture a scenario where Earth's rotation slows by just a fraction of a second each day. It may seem minor at a first glance, but compounded over months and years, this subtle shift could accumulate into highly noticeable and transformative changes across the planet. Among the most immediate and tangible effects would be a gradual lengthening of both our days and nights, as a slower rotation extends the periods of sunlight exposure and prolonged darkness, reshaping the balance that governs our world. Such extended daylight would accelerate plant photosynthesis and growth in some areas, while prolonged nights could disrupt sleep patterns in animals and humans alike, profoundly impacting delicate ecosystems, migration timings, and even agricultural cycles dependent on consistent light. Moving beyond the simple day-night cycle, a slowing of Earth's rotation would carry significant and far-reaching consequences for our planet's overall climate systems and intricate weather patterns that sustain life. Central to this is the Coriolis effect, a direct result of Earth's rotational speed, which causes the deflection of moving air masses and ocean waters to the right in the northern hemisphere and to the left in the southern. If rotation slows, this Coriolis force would weaken considerably, resulting in less pronounced deflections and thereby leading to altered paths for global wind systems, major ocean currents, and the overall dynamics of atmospheric flow. These shifts might trigger more extreme weather events worldwide, such as extended droughts cracking the soil in arid regions, contrasted with deluging rains and severe flooding overwhelming river basins elsewhere. It will almost immediately result in severe disruption of agriculture, food supplies, and freshwater resources. Additionally, the planet's heat distribution would realign, with slower rotation potentially amplifying temperature contrasts between the hot equatorial belt and the frigid polar caps, exacerbating polar ice dynamics and mid-latitude weather extremes. Moreover, such a rotational slowdown could subtly influence Earth's protective magnetic field, the invisible geomagnetic shield that envelops our planet and guards against the sun's harmful radiation and cosmic rays. This vital magnetic field is generated deep within Earth's molten iron outer core, where convective currents of liquid metal, driven in part by the planet's rotation through the Coriolis mechanism, create electric currents that produce the field. A marked slowdown in rotation might diminish these dynamo effects, weakening the magnetic shield and allowing greater penetration of solar radiation. Compounding these natural challenges, our modern technological infrastructure, especially precision-dependent GPS networks and orbiting satellite constellations, would encounter severe operational difficulties from even minor rotational variances. GPS and communication satellites depend critically on exact orbital mechanics, precise atomic clocks, and flawless predictions of the planet's spin for accurate positioning and timing. Consequently, a slight rotational drift would demand ongoing recalibrations of these systems, risking widespread navigation inaccuracies for aviation and shipping, as well as blackouts in satellite communications and data services we rely on. In totality, the cascading effects of a slowing Earth rotation could prove catastrophic, unraveling global ecosystems through biodiversity loss, destabilizing climates, and fracturing human societies dependent on reliable technology and food chains. Thankfully, while Earth's rotation does exhibit minor natural fluctuations due to tidal frictions and internal mass shifts, scientists assure us that no significant or sustained slowdown is anticipated in the foreseeable future. Yet, contemplating these hypothetical scenarios deepens our appreciation for the balance that sustains our planet and biological life. This perspective emphasizes the interconnectedness binding all natural phenomena from atomic scales to planetary, and reinforces the crucial role of ongoing scientific inquiry to decode and safeguard our world. From the eternal rhythm of day breaking into night, to the grand swirling dance of ocean currents and winds, Earth's spin serves as the silent, masterful conductor orchestrating the symphony of life. It is this unwavering, steady rotation that guarantees the stability, predictability, and harmonious conditions upon which all terrestrial life depends for survival. Thank you sincerely for joining this captivating exploration into the mechanics of Earth's rotation and the intriguing vulnerabilities that could arise if it were to slow even slightly. If you found this video informative and thought-provoking, please show your support by liking it and subscribing to our channel for more in-depth, fascinating insights into the wonders of our universe and the science shaping our world.